Good morning, John. A little over a year ago, we observed the first ever object that wasn't from here. A hunk of something that had traveled from another star system, maybe thrown out as the system formed, maybe flung out much later. But now we know, officially, while we cannot visit other star systems, pieces of them can visit us. And Oumuamua is not what we expected. Let's start with what we know. An object came into our solar system, going around 25 kilometers per second, which is pretty fast. It was varying in brightness, so we'd look at it one day and it would be 10 times brighter than on another day. A huge surprise, which is where we got the cigar hypothesis. It was, they supposed, long and skinny, so when it was like this, it reflected more light than when it was like this. It was tumbling end over end, changing in brightness. There are no objects in our solar system shaped like this. Oumuamua has a length to width ratio of 10 to 1. There are barely any objects in our solar system with a ratio of 5 to 1. How would an object like this form? We don't know. What would it be made of? Probably something very sturdy, or else it couldn't maintain this strange shape. It brushed surprisingly close to Earth, right into the habitable zone of our sun, and then, maybe the weirdest bit of all, its velocity changed in ways that could not be explained by gravitation alone. There are, as far as we can tell, only two ways this could have happened. One, Oumuamua is a comet, and it off-gassed 10% of its mass as the sun heated it up, and this is what comets do. It's what gives them their big, beautiful tails. Or two, instead of being a big rock, it's a 50-meter square of shiny foil less than a millimeter thick, which fans of space travel and/or science fiction will recognize as the description of a solar sail. See, weirdly enough, photons do not have mass, but they do have momentum, and when they hit something, they give it a tiny push. A big sheet of something very reflective but very lightweight can take advantage of that fact and use it for propulsion, something we humans have actually experimented with. But look, that can't be right, right? Obviously, a comet is a much more likely thing to have floating through interstellar space. But until we noticed the velocity change, we were pretty sure that Oumuamua wasn't a comet. For one thing, it was long and skinny, and that is a shape that is very difficult to have occur naturally at all, but even more difficult if it's not something that's rigid. And comets generally are fairly loosely held together balls of ice and dust. The idea is that would definitely break apart, especially as it approached a gravitational well like our sun. Now, it's certainly possible that the change in brightness isn't caused by its unique shape. It could be that it's just much darker on one side than the other, like Saturn's moon Iapetus. So maybe we've just learned that it isn't such a weird shape. Also, we didn't think it was a comet because there was no tail. As it off-gassed that theoretical 10% of its mass, we probably would have seen some of that mass. But maybe there are comet-like things from other solar systems that outgas differently from our comets. Different compounds, different sized dust particles that would make it more difficult for us to detect. And finally, scientists think the off-gassing would have changed the rotation of the object, which it appears to not have. Now, adding to the solar sail hypothesis, the Spitzer Space Telescope pointed at the place where Oumuamua was, and it did not receive any thermal readings back, no infrared radiation, meaning that it was very dim in the infrared, so probably it had reflected away most of the heat it received from the sun. This is maybe the weirdest thing. It means that the object has an upper limit on how dark it can be, and that limit is shinier than either asteroids or comets from our solar system. Which, thank you, Spitzer Space Telescope, this was not what you were designed for, but that is very helpful and weird piece of data. And then there's this. This shouldn't have happened. The telescope that spotted Oumuamua does a whole sky survey and is not designed to catch things like this. In fact, it didn't spot the object until it was well past its peak brightness. The fact that the Pan-STARRS telescope caught an object like this in the first 10 years of operation means statistically that these events are probably very common. But according to our computer models of how solar systems form and how much stuff they throw out, it should not be common. And this discovery, if it's natural and common, means that we were off by orders of magnitude. And it's actually wonderful news that it did occur, because if it means it's more likely, then we will have more chances to study objects like this in the future. Because we definitely do not understand what this thing was. I don't know, maybe there's a natural way for a solar sail-like object to form in the galaxy, who knows? In general, jumping from this is confusing and weird and I don't understand it to it's aliens has tended to be a bad way to answer questions in the past. And as Carl Sagan said, extraordinary claims require extraordinary evidence, which we, as Oumuamua speeds off away from us, do not have and will never have. Now, of course, arguing against the extraterrestrials created a light sail hypothesis are two main things. One, why would it be tumbling end over end? If you wanted to create a space probe to study a planet, you probably would want to keep everything relatively stable so that you could point stuff at the planet to study it. Two, why is it going so slow? 25 kilometers per second is very fast to us, but very slow in terms of interstellar travel. It would take about 12,000 years if you were going straight at Alpha Centauri to get there from here at that speed. This leads to alternate hypotheses like, hey, there are more shipwrecks under the ocean than ships currently floating on the sea, so maybe this is the piece of something that broke down or ripped apart through age or accident or attack. It's artificially created, but it's 100% dead just floating through space, because if we're gonna start hypothesizing, we might as well start hypothesizing about interstellar war. But unless this is an extremely uncommon occurrence, debris from an event like that would have to be way too common. Like, I would just be very sad if there was that much detritus floating around in the galaxy. A theory I haven't heard from anyone except my own brain is that maybe this thing is tumbling end over end and not going very fast because whoever sent it wanted us to see it. Maybe they thought if there was some group of intelligences significantly advanced, they could chase such an object down. Maybe it's nothing more than an interstellar greeting card, blinking off into the distance, unreceived. This time at least. I shouldn't have said that. That was pure conjecture. And I probably shouldn't even be making this video at all. As a person who hosts a science show, has a master's degree, and looks like this, I am credible, and I want to hold on to that credibility and also use it wisely. Observing an interstellar object on its own is huge news. It means that these objects are more common and more weird than we thought. But the story that would truly captivate all humanity is if we found out for sure that this thing came from somewhere else, someone else. How captivating an idea is for our minds should not have an effect on how scientists consider that hypothesis, but it does have an effect on how it is perceived by us. It has an effect on how we're going to write that headline, make that video, and whether we're going to click that link. As a science communicator, I'm aware that people are going to see the sentence, "This is probably not a spaceship," and see more of the probably part of the sentence than the is not part. So I'm aware that bringing up the possibility that there is explanatory power behind the hypothesis that Oumuamua was constructed by an intelligence outside of our solar system is going to inevitably lead people to looking much more at that part of the story than the parts where there might also be lots of other explanations. This is, for example, true of me, because I want it to be a spaceship. I want to know a new story. I want to have an event like that, where we all remember where we were when we heard the news, not the bad news, just the big news. So ultimately, I know that I'm not going to be able to trust myself with this one, you know? I'm trying to look at more things that way, knowing that there are certain things I can't really trust myself with because I want things to be a certain way. And it's especially easy to see in this case where the event was ephemeral, the data have been collected and analyzed, and now all that we have left to do is speculate. Or maybe that isn't true. Right now, we have only one telescope that could have spotted Oumuamua. Another is going online in just a few years, and it will be orders of magnitude better. If, when we get that telescope online, we see objects like this flitting through the solar system all the time, we may be able to determine that they are a new class of object, to understand them, study them, even visit them. Or we could find that Oumuamua-like objects are rare. And well, then we'll know that we saw something special. And that will be a big deal. But maybe the best argument against the alien hypothesis is simply that the universe is weird. Many times we've seen things in the night sky and had no way to explain it and thought, oh, this is it. Now we find the others, and then science caught up to observation. This is an object unlike any we have ever encountered before. So maybe the fact that it's weird isn't actually that weird. John, I'll see you on Tuesday. I read a lot of good articles, listened to a lot of good podcasts, watched a lot of good videos prepping for this one, so I've linked to some of those in the description. Thanks to all of the scientists who worked on this project, got together very fast to make this happen, to start observing once we realized that we had something weird on the radar. Educational videos are exempt from the 4-minute rule, obviously, just saying it. And the projects were awesome. Please do that. Get it ready, because we will, as a community, next weekend be voting on which of the charities promoted in those videos will be getting grants from the Foundation to Decrease World Suck. So, action, do it, boom, excited. We're Project for Awesome's coming. Thanks to the educational video exemption for allowing me to just ramble on for a while. John, I already did that.